These are your 7-3A notes on logarithms and logarithmic functions. Today you're going to first figure out and be introduced to what a log is, and then we're going to practice just putting equations of logarithmic form in logarithm form, or we can also write logarithms that look in exponential form. So that's kind of the focus of today's lesson. So before we can explain what a logarithm is, let's look at an exponential function. So the first two sections of this chapter involved exponential functions. So if you look at a t-table of y is equal to 2 to the x, remember that's a parent. It has a base 2. And so if I plug in 0, I get 1. If I plug in 1, I get 2. When I raise 2 to the second power, I get 4, and we'll just go 3 gives me 8. So when I plot those points over on this graph over here, I'm just dealing with the positives right now. 0, 1 is my y-intercept. 1, 2, 2, 4, and 3, 8. And so I have exponential growth. So I'm rising up to the right. And then I'm going to use the x-axis as my horizontal asymptote. So that is the original function. Way back in, I believe, chapter 4 or 5, we started talking about inverse functions. And if you recall, an inverse function is when you flip-flop the x and the y values. So right next to this, I have the inverse function, where instead of having y is equal to 2 to the x, I have x is equal 2 to the y. Now, we really don't know how to solve for y and get that by itself. But if I just use the tables, if the original was 0, 1, then my inverse would have the ordered pair 1, 0. If the original was 1, 2, if I flip-flop that, I get 2, 1. And if I have 2, 4, I could have 4, 2, right? Inverse relations are just flip-flopping the x and the y. So I'm taking the original function and I flip-flopped the x and the y from the table. It still holds true if I plug the y value of 3 into this inverse function. 2 to the third does in fact give me x as 8. So I'm going to plot these. 1, 0 happens to be now an x intercept. 2, 1, so I'm going to go over 2, up 1, over 4, up 2, and then over 8, up 3. So you can see how we're moving over more than we were moving up. We're moving over the same amount that we moved up in the original. And so what this creates is a sort of a growth sideways. It's going to be on its side now. It grows in the same fashion that the original would grow upward. It grows to the right. And then instead of having a horizontal asymptote, we now have a vertical asymptote. So the asymptote here of y equals 0 is now the vertical x equals 0. And when we studied inverses, we said that every single function and its inverse are symmetrical along the identity line. And so if I draw that identity line in there, you can see, I mean, I know it's a sketch, but the blue and the green branches would match up for every point. So that tells me that the blue graph and the green graph are inverses. We did this back in chapter, I don't even remember now, where we talked about the inverse of square root function. So we had the quadratic and then we had the square root. And the square root was just a parabola on its side. So the inverse of an exponential is just an exponential graph turned to the right, rotated to the right 90 degrees. So that graph, that green graph, that inverse, is actually what we call a logarithm. So it is the inverse function of an exponential. So we give it its own name. Just like when we graphed parabolas and quadratics, they were x squared. And so when we took the inverse of it, rather than calling it the inverse of a quadratic, we gave it its own name, and we call it square root functions. So this is just the inverse of an exponential, but we give it its own name, and now we call it a logarithm or logarithmic function. So the inverse function is called the logarithm of x, and there's a little bit of a symbol for that. So This is what they look like. A lot of times they won't have the y there. I'll show you. It will just read log base b of x. That's usually how they're shown. But if we are going to graph them, they would have the y value. So the y value equals the log base b of x. So when you talk about a logarithm, you are actually describing the exponent of the inverse of an exponential. We are describing what that y value is. We are giving you the exponent. So a lot of exponential rules will apply to logarithms. So today, all we're going to do is work on changing back and forth, rewriting logarithms in exponential form or in logarithmic form. Now, I do want to clarify that when I say we're writing it in exponential form, we're writing it the inverse in exponential form. So from here on out, we're talking about the inverse of an exponential. So if you look at the actual exponential form, it's not y is equal b to the x, it's x equals b to the y. And here is the logarithmic form. They each have a base, they each have an x, and they each have a y. So today's lesson is all about making sure we understand where all those parts go, because part of solving these things and working with logs is being able to transform an exponential into logarithmic form or a logarithmic back into exponential form. So you should be able to transfer back and forth. I would compare it to being able to write a fraction as a decimal or a decimal as a fraction, being able to go back and forth. So in the beginning, it's just going to take some repetition. I'm going to label all my parts. So if you look at the exponential up above, this is your base, this is your y value, and this is your x. So now I'm going to look at the log, and I'm going to read that log base 5 of x of 125 is equal to y, which is 3. The log base 5 of 125 is equal to 3. Now I do want to note, when you write logs, this is your paper right here. That's the line of your paper. Notice that the 5 is subset. You know how we put exponents up superset, they go above the text. This is a subset. So it's smaller, it's written smaller, and it is below the line. So make sure you do that because it does throw some things off. If you don't, that could almost look like 5,125. And if you're missing a number here, it actually means something mathematically. So you don't want to misconstrue that. What you're really saying when you write this down, what you are really saying here is you're saying, what number do you raise 5 to get 125? That's what a log asks. Remember, a log is describing the exponent. What would you raise the base 5 to get 125? And the answer is 3. Okay, so in this next problem, my base is 27, my x value is 3, and my y value is a third. So log base 27 of 3 is equal to a third. What would you raise 27 to make 3? You would have to raise it to the third power, which is really taking the cube root of it. So all I need is that you rewrite it this way. Let's try it one last time without having to write and label the b's, y's, and x's. But this is just going to take some time to get used to. Log base 2 of 16 is equal to 4. And remember what you're asking. What number do you raise this base 2 to get 16? And the answer is 4. Okay, going the other way, if I give you the logarithmic, this way is a little bit easier because it makes sense. If I give you the logarithmic, you guys come up with the exponential. And so I know you can't see it, but the exponential of a logarithm is b to the y equals x. And I do not see where this, this 100 is actually supposed to be under here. I apologize for that. It's just kind of random there. So to rewrite log base 3 of 9 equals to 2, we got to label and all of our stuff. So this little number here is the base. The number next to it is x, and we're describing what y is equal to. So we need to change that form into 3 to the y power squared is equal to x, which is 9. This should hold true. Mathematically, 3 squared should equal 9. That's kind of a good point that if you had them in the wrong order, you know you're wrong because it doesn't hold true. If you had 2 cubed equals 9 or 2 to the 9th equals 3 or some other form of that, it would not hold true. Once again, we got the base here. This whole fraction is my x value, and this is my y value. So base 10 to the negative second power is equal to 1/100th, which is true because when you have 10 to the negative second, it would flip the 10. You square it, you get 100, so you'd have 1/100. And the last one, 2 to the fifth power is equal to 32. So you raise it to the y and it equals the x, and this is also a true statement. So pretty simple. A logarithm is an inverse function of what type of function? And your practice problem, I want you to put that 2 to the 6th into logarithmic form. Good luck.